fabulous good afternoon to everyone. Let me introduce me first. Myself, I am Udeshri Swaro, passing grade 1st MPC from TTWREIS Sudimalla. Before entering to our topic, let me discuss something. Yes, one day one old boy went to the supermarket market to purchase shampoos. But in the supermarket market, all are arranged at the clumsy way. He can't understand what he was taking. What is need there? Yes, it has to need classification and arrangement. If we are arranged in order, it will very easy to take anything or to purchase anything. Yes, today we are going to discuss about the classification of modern periodic table. In 1880, only 31 elements were known. In 1865, only identified elements were doubled to increase 63 elements. Total, there are 118 elements were present in the modern periodic table, and still the elements were still continues going on, and every element has its own importance. Some of them are useful and some of them are harmful. Harmful also useful, like the radioactive elements. With a large number of elements, it is very difficult to study in chemistry. In all these elements, it is numerical compounds individually. Periodic table is a tool which is used to classify the elements in groups. Periodic table also useful to analyze the periodic trend in various ways, such as the ionization enthalpy, electron affinity, electron negativity, and metallic character, non-metallic character, melting point and boiling point. Yes, this classification of the modern periodic table mainly done by the four main scientists. First one was the Doberainer, second one Newland, third one Mendeleev, and fourth one was the Henry Moseley. We will discuss more briefly about these four scientists. First, we will discuss about the Doberainer law of triads in 1829. Doberainer was the first scientist to introduce the elements in groups. He tried to classify the elements in similar properties in groups in 3 elements like triads, but he could only succeed in making few triads. They each tell the triads of the middle element is the arithmetic weight of the middle element or the weights of other two. Let's see, have a glance please. Here we are seeing lithium with atomic weight 7 and potassium with atomic weight 39 and sodium with atomic weight 23. If we add the weights of lithium and the potassium, then we will get the sodium weight by doing average. But why Doberainer has went to limitation? What is the reason behind that? Yes, we will know about that. Doberainer could arrange only few elements in triads, but there were such elements present in triads. They are arranged according to their atomic weights are approximately equal. For example, ferrous, cobalt, nickel, they have the same atomic weight, but Doberainer had arranged in the triads. So it also went to the limitations. Next one, Newland law of triads in 1865. Octets in 1865. In 1864, an English chemist, John Newland, noted that every 8th element has the chemical and the similar properties of elements when he had arranged the elements according to the increasing order of their atomic masses. Then that elements are called as Newland's law of octets. When the laws are arranged according to the increasing of the atomic masses, he had arranged the properties and again the 8th element was repeated. Newland law of octets was determined by the Indian musical note Sarigama Padani. After that it was again repeating Sarigama Padani, Sarigama Padani. And why this also went to the limitation? Why the law of octets was not came into the exist? Yes, let's see. Here, This law is only applicable up to the calcium. It can only contain the 56 elements. Further, we cannot discard any no more elements in the new lands. Yes. Have against please cobalt and nickel had the different chemical properties, but Newlands was arranged accordingly. It is in the same group, so it also went to the limitation by this fluorine, chlorine, etc. These are all elements are arranged in the same column. Next, Mendeleev periodic table. Properties of elements are the periodic function of the atomic weights. Mendeleev periodic law states that every physical and the chemical properties of elements are the periodic function of the atomic weights. Elements are arranged according to the increasing order of the atomic weights. After regular intervals, the similar properties are again repeated. Mendeleev research was based on only 63 elements were known at that time. He has studied only relation between the atomic masses and the physical and the chemical properties of the elements. He had arranged the vertical column called groups and horizontal rows called periods. And he had, when arranged according to the vertical column, he had leave some backspace which the elements are till known or discard. This was a Mendeleev periodic table which has prepared by the Mendeleev, and here we are seeing these are the periods and these are the groups which are based on the atomic weight. But these elements are also called as transition elements. Why the Mendeleev periodic table also not exist? Yes, he had arranged according to the increasing of the atomic weight. What is the mistake? Yes, it also having some demerits. Position of hydrogen. Position of hydrogen resembles both alkali and halogen, but in the Mendeleev did not give any space to the hydrogen. Position of isotopes. Position of isotopes are differ, but they have similar and the chemical properties. But in the Mendeleev periodic table, they had no space for the isotopes. Anomalous space of elements. It has arranged according to the increasing of the atomic weight. But cobalt and nickel are placed before the potassium with higher weight, so it also went to the limitation. Like elements were placed in different groups. For example, platinum, gold are having the different properties, but he have arranged in the different groups, so it also went to the limitations. Now our modern periodic table was mostly prepared by the Henry Moseley, and he was the English chemist in 1913. And modern periodic law states that a physical and the chemical properties of elements are the periodic function of their atomic number. Position of elements in periodic table. Modern periodic table consists of 18 groups and 7 periods. The elements are present in one group have the same number of valence electron, and it also increases the number of shells down to the group. And the elements are present in only one period contain number of shells by increasing the atomic number by 1 unit only. Moving from left to right, valence electron increases by the 1 unit. Each period makes new electronic shell getting filled. And now we will discuss about the salient features of the modern periodic table. Modern periodic table are placed and arranged according to the 7 horizontal rows and 18 vertical columns in the Henry Moseley periodic table. The elements belonging to the same group and having same number of shells and it having the period number. Each period starts with the new electron orbit and ends with the 7th period, and it having the 7 periods we have discussed. Yes, first period mainly consists of 2 elements called shortest periods. 2 and 3 period having 8 elements, we call it as the short period, and 4 and 5 consist of 18 elements, we call it as long period, and 6th period consists of 32 elements, which is longest period, and 7th group mainly consists only 23 elements to 32. It has incomplete period. Till now it has not filled. This group are arranged according to the number of electrons and outermost orbit of an atom. In the same group have same number of shells of outermost electronic configuration. And yes, we had discussed about the groups and periods. In detail, we will discuss about groups and periods. Modern periodic table has 18 vertical columns called groups that are arranged from left to right. Group 1 elements are mainly known as alkali metals. They form strong alkyne with water. Group 2 are called alkyne earth metals. They are formed alkyls less than the first group. Group 13 to 12 are transition elements. Group 13 boron family. Group 14 carbon family. Group 15 nitrogen family. And group 16 oxygen family and also known as chalcogen family. Group 17 halogen family. Group 18 noble gases or inert gases. Now periods. There are 7 rows in modern periodic table. They are known as periods. Yes, this was the modern periodic table which has prepared by the Henry Moseley. Mainly it consisting of total 118 elements. This modern periodic law states that a physical and the chemical properties of elements are the periodic function of the atomic number. And the physical and the chemical properties of elements are not depend only upon the number of protons. They will depend only upon the number of electrons. And these we are seeing here, these are all we are called as periods, and these are all we are called as groups. Periods are mainly interlinking with the principal quantum number and groups with the half-bow principle, and this is called as the S block elements, and these are D block elements, these are P block elements, and these are the D block elements. Here the representing of colors. This one is a alkali metal, these are the alkali earth metals, these are all metals, and here seeing these are all base metals. Here yellow color is semi-metals are called as both acting metals and metalloids. And here we are seeing non-metals. These are the halogen family, and this is noble gases or inert gases. Here we are seeing lanthanoids and actinoids. Here this subshell only consists of one orbital and increases and accommodates to maximum number of 2 electrons. Now P. Here this P subshell only consists of 3 orbitals and it also accommodates to maximum number of 6 electrons. And now D. This D subshell also having only the 5 orbitals, and next it also accommodates the 10 number of electrons. F block also consists of only 7 orbitals. It also accommodates the maximum number of 14. And the Roman numerals has indicated this arrangements 1 through 8. By the latest recommendation of the IUPAC has arranged the groups according to 1 through 18 has Arabic numerals and periods 1 through 7. And these are periods interlinked with the only principal quantum number. It denotes K, L, M, N, shell, and 1, 2, 3, 4, so on. This K, M, L shell first periods is consisting with first main shell K shell. K shell having only one subshell, that is L shell, with electronic configuration 1s1 and 1s2. Its total consists of two elements, hydrogen and helium. Second period is starting with second main subshell L shell. L shell also consists of two elements that are 2s2 and 2p. This also consists of mainly 6 elements in the second period. 2 is from S block and 6 is from P block elements. And third subshell also mainly consisting with the third main subshell, that is the M shell. M shell also having 3 main subshell, that is 3s, 3p and 3d. Why are you getting? Yes, after completion of the 3s only, it will enter to the 3d. Next, it also consisting of the total 8 elements, and 2 is from S block and 6 is from P block. Fourth main subshell is continuous with the period, and the shell is fourth shell. Fourth shell mainly consisting of 4 main subshell, that are 4s, 4p, 4d and 4f. These are mainly consisting of the 18 elements. 2 is from S block, 6 is from P block and 10 is from D block. This was the model periodic table as introduced by the Henry Moseley. This is the information about this. We will discuss further about these blocks: S block, P block, D block and F block. In modern periodic table, every element consisting of atomic weight, atomic number, symbol, etc. Yes, we had discussed this is one metal is known as alkali metal, 2 group alkali earth metals and 3 to 12 transition metals, 13 to 15 is known commons and 16th is chalcogen, 17th halogen and 18th are noble gases or inert gases. Yes, now we will discuss about the S block, P block, D block and F block in more. Here we are seeing S block elements. First, we will enter to the S block elements. The differentiating electrons enter into NS subshell, then that elements are called as S block elements. The general outermost electronic configuration is NS1 or 2. Total it are arranged in 2 groups. One is 1A group and 2 is 2A groups. These here 1A group starts from lithium to francium and 2A group will start from beryllium to radium. These are the metals which are presented. These are all the representative elements and having the nature of shiny nature and soft nature and the colored nature. Yes, we are getting one doubt. Why this hydrogen has placed separately from the modern periodic table? Here it having only one valence electron in its configuration. So Henry Moseley had placed this hydrogen at the top of the periodic table. And these 1A group metals are mainly alkali metals and 2A group metals are alkyne earth metals. Why these are called alkyl metals and alkyl earth metals? What is the reason behind that? Yes, due the name of alkali means it have we obtained from the plant ash. The elements which we are obtained from the plant ash that elements are alkali metals, alkyne earth metals. The elements which we are obtaining from the earth resource, then that elements are alkyne earth metals. Mainly the shape of this S block elements is spherical shape. And now we are entering to the P block elements. The differentiating electrons enter into NP subshell, then that elements are mainly called as P block elements. This general electronic configuration is NP126 NS1R2. These elements mainly arranged from the 3A to 18. This is a 3A and 4A and 5A, 6A, 7A and 8. And this is the elements which are presented here. And now these mainly having the noble gases. These are all gases which are presented in the 18th group. But it is the halogen family and it is the chalcogen family. It is nitrogen, carbon, boron, and it having presented here carbon, nitrogen are mainly both acting as the metals and non-metals. So these are metalloids. And next we are entered to that block, and these are all the metals which are presented. Nitrogen and oxygen are non-metals. Aluminium, gallium and tellurium is the metals. And it is the shape of this P block elements is mainly spherical shape. Now we are entering to the D block. The differentiating electrons enter into N-1 D 1 to 10. Then that elements are D block elements. The general outermost electronic configuration is N-1 D 1 to 14, and it has mainly arranged through 3B to 12B. Mainly it's consisting of 4. 3D series, 4D series, 5D series and 6D series also. 3D series starts from scandium to zinc, and 4D series starts from yttrium to cadmium, and next lanthanum to mercury and actinium to UUB. But it having a special nature. Special nature, what is that? Yes, it all are representative elements and have colored nature and increasing the electronic number of shells. That's it. Now this D block elements shape is double shape. Now we are entering to the F block elements. The differentiating electrons enter into N-2 F subshell, then that elements are called F block elements. The general outermost electronic configuration is N-2 F 1 to 14 and N-1 D 1 to 10 NS1R2. These are arranged in 2 series, 4F series and 5F series. 4F series mainly called as lanthanoid series and 5F series are actinoid series. The shape of this F block elements is mainly 4-4 dumbbell shape. Now we will discuss about the periodic trends of the table. The repetition of elements at certain regular intervals at electronic configuration is called periodicity. Mainly it has divided into 5 parts: atomic radius, electron affinity, electron enthalpy, negativity. We will see here. Atomic radius in a group from top to bottom, atomic radius increases. In a period from left to right, atomic radius decreases. Ionization enthalpy in a group from top to bottom, ionization enthalpy decreases and ionization enthalpy in a period increases. And electron affinity. Electron affinity also in a group it will decreases, in a period it will increases. Metallic character in a group it will increases and in a period it will decreases. Non-metallic character in a group it will decreases and in a period it will increases gradually. And daily life applications of the modern periodic table. These elements is day-to-day life we are using in our life. But chlorine helps us in animals to digest food. Iron helps us to carry blood around the body. And glass contains silica, it makes strong. And these are some valuable metals which are using in our day-to-day life. Gold, aluminium, platinum, etc. These are the big factors of the elements. Without these, we can't do any mining. And here see, have a glance please. This is the application of the modern periodic table, and lithium is useful in our day-to-day life. All 118 elements will use in our day-to-day life. For example, and I am saying thanks to the Dimitri Mendeleev and others for the periodic table which have arranged by the increasing of their atomic number. And especially we have to thanks to Henry Moseley also for introducing the correction and recover the Mendeleev periodic table, and by the Henry Moseley periodic table according to the increasing of the atomic number. So, I am saying thanks from my bottom of my heart to Telangana government and tribal society, and once again I am thanking to our dynamic hero and supreme sparrow of our TTWREIS. He is none other than our below secretary R.S. Praveen Kumar Garu, and my principal ma'am Sri Arna Kumari madam, and my mentor teacher Kantarao sir, and my VP sir, and all my staff who has supported me, and my parents, my brother, and thank you for giving this wonderful opportunity for me.